Hello everyone, here's another IB Physics past paper review. This is page 8 of May 2018, standard level paper 1, and this is question 14. We have two travelling waves moving through a medium. Diagram below shows for a point in the medium, the variation with time of the displacement d for each of the waves. So here we can see we've got two different waves. Let's look at this one first. It goes up, it comes down, it goes up, it comes down. And this one over here starts up and comes down and up and down. So some key features to note. Let's go ahead and, before we even answer the question, let's think about what's happening. Let's say that this is the peak of the red wave here. I'm just going to call this red, and this is the other peak. So peak to peak is going to be the period, right? So this is our period, t. So let's work out how long that takes. The period is going to be, one period is going to be, well, this value here is 1.3, I think, milliseconds. And this value here is 6.2 milliseconds. So it's going to be 6.2 minus 1.3. That's going to give us 4.7. Okay, so one period, takes 4.7 milliseconds. There we go. Now, when we talk about phase difference, we refer to it in degrees. So, of course, a full period would be 360 degrees. So 360 degrees would be equal to this, or the time frame would be equal to 4.7 milliseconds. So if we took the period and put it in half, that would be equal to half of the 360. In other words, that would be equal to a phase difference of 180 degrees. And if we keep going with this, if we took the period and divided it by 4, that would be equal to 90 degrees. And we could keep going, of course. Period divided by 8 would be 45 degrees. So in the question, let's look at the first bit of the question. We're asked to consider a time interval or a time point on here. It's 2 milliseconds. We're asked, what is the phase difference between the waves? And what is the resultant displacement of the waves at this time? Well, the phase difference will be the same wherever we are, so we don't need to worry about this 2 milliseconds. We just need to think about this period value. And the options we have are 45 or 90. So it's quite simple. We're just going to divide our 4.7 by 4 and see what we get for that. And we're also going to divide it by 8 and see what we get for that. So 4.7 divided by 4 gives us 1.2 milliseconds. And 4.7 divided by 8 gives us 0.6. So I'll just leave it like that for now, milliseconds. Okay, so if the answer was 45, we would expect the time difference between the peaks, or from whatever point on either of the waves, to be 0.6. And if it was 90, we would expect the time difference between them to be 1.2. Well, hopefully you can see just by eyeballing it, if we take this peak here and compare it with this peak here, so this peak from, let's call this the blue wave, and let's call this the red wave, let's count these across. Well, it's 5 to 6, so that's 1, and then 0.2. So that's a clear indication, hopefully it's really obvious, that this is the time difference between the waves. And when we convert that into a phase difference in terms of degrees, it's going to be 90. So right away, we know that the answer must be either B or D. Okay, let's keep going now and answer the rest of the question. We're asked to consider a value at 2 milliseconds. So it's going to be here. And we need to know the resultant displacement of the waves. So resultant displacement means we're going to add them together. We're going to add this part of the wave to this part of the wave. And so we need these values. So this one here is going to be +1. So we have a +1 And this part here is going to be 1.6 or negative 1.6. So let's add those together. So we're going to go, let's do it over here. We have a plus 1 plus the negative 1.6. And hopefully you can see that's going to give us the resultant displacement of negative 0.6. So that's this one or this one. So clearly the answer is D. Okay, so for question 15, we're asked to identify a fringe width or one fringe width on an interference pattern. Looks like it's in water or some kind of liquid, and there's two sources here, and obviously the waves are emanating out from the two sources, and in here we're seeing all this interference pattern appearing. Now, I just want us to think about how we would normally draw double slit or diffraction grating questions. We would have our diffraction grating or a double slit over here. Here are the two slits. And then we would show this geometrically that we can represent this as these triangles with the maximum constructive interference appearing right in the middle, called the central maximum. And then we're going to have these bright fringes either side. Of course, in between the bright fringes will be a band of dark fringe. So we have this bright spot, darkness, bright spot, darkness, and we'd obviously keep going. There'd be another one here, which we would call N2, and then that would be the same as down here, and so on. So a fringe is referring to the distance between two bright spots, or the distance between two dark spots. It's really the gap between these guys here. So looking at our diagram, hopefully you can eliminate A right away. It's not going to be A, because A is going to be the wavelength. Actually, that'd be, let's go, something to do with wavelength. And then D is spanning, well, an entire fringe plus a half, plus another half. So this would be two fringe lengths. So D would be represented as being from here, halfway between the dark, covering a full fringe, and then being over here. So it's not D. B is starting at the edge of one dark fringe and halfway between a dark fringe. So B would be as if it was going from here to here. So that's not a full fringe, which leaves us with C, which is crossing an entire dark fringe. So that would be equivalent of going from somewhere like here to here, spanning an entire dark fringe. So the best answer we have here is C. C.